This agenda for today's meeting. Click to Cloud team is going to give a presentation for the contribution they've done to our Fornex Edge project. But before they do that, I just want to take a few minutes, just briefly housekeeping item. We had two voting for two items. One was the last month's presentation of Quad project to be incorporated as part of Centaurus. So we got a approval for that. So 5 out of 7 TSC members replied and they were in favor of it. So that's approved. So majority voting. And then we had a couple of months ago, we had the meeting, the voting for the all community members to be allowed as part of the TSC meeting. So now that was approved unanimously, actually 7 out of 7. So now anybody can join this meeting. So whoever is on this call, feel free to invite whoever wants to kind of participate, propose any agenda item, and then if they want to bring up something, feel free to do that. Actually, so it's not just a TSC members meeting; it's an open community meeting. So the intent is to kind of expand the community participation. So that's just wanted to kind of mention that even though this voting happened a couple of months ago, I just want to repeat that again. So that Click to Cloud folks or anybody you folks want to bring in and they want to propose something, changes or anything, feel free to do that. So anybody can chime in. Okay, I think so that's pretty much it. I just wanted to cover the housekeeping thing. And then with that, I don't know, whoever is going to take over. Roshan, you want to?
Yeah, hi, Deepak.
Yeah, hi, Roshan. Hi.
So
let me stop my screen.
Sure.
Go ahead.
Yeah, so we have worked on Fornex project like
you gonna share something on the screen?
Yes. Okay. Nagaraju, can you share?
Yes, sir.
So Deepak and team, we have worked on Fornex projects like on automation scripts, and recently we have worked on like the Golang code, in which we have on the single edge, we will have multiple clusters. So Nagaraj will explain the architecture and the development we have done so far in this project, and we have generated PR on which Peng has reviewed and gave some comments, and also we have resolved that one. So over to you, Nagaraj. Start.
Yeah, thank you. So let us directly get into the details. We all know every edge core has its own cluster-D module, and earlier this cluster-D module was able to handle only a single Kubernetes cluster, and after that, Click to Cloud's task was to. So earlier the case was like this: it was able to handle only a single Kubernetes cluster, and now Click to Cloud's task was to make it enable to handle multiple clusters on the same level. So a single edge core. So the cluster D inside the edge core has to handle multiple Kubernetes clusters, which we were able to successfully solve, and we have raised the PR2. And later we have checked this with the already existing environments like hierarchical environment and single cloud core connected to multiple edge cores in this way, and we were able to find good result. And later earlier according to the demo, it was like the Kubernetes cluster that you are going to connect to the edge core, we have to place it under the root directory. So to make it a bit unique, we have shifted this path to etc/fornex/config, and that was a change. Yeah, I think that's it. I can show you a quick demo. So here my cloud core is up and running. Let me get my edge core running. if you say now, I'm going to deploy this mission into a cluster named server one. So this is my cloud core and this is my edge core. This is an external Kubernetes cluster that I've connected to this edge core. So I'm going to deploy this mission from cloud core to that server one. Server one is this one.
This is deploying from the cloud, right?
Yeah, from the cloud. So our mission is created. This is our edge core. If we check here, so we haven't added this particular. This edge core will be already having its own Kubernetes cluster. So we haven't added the kubeconfig of this. We have added this. So you see, our mission got deployed here.
The server one cluster is the name of the Kubernetes cluster.
Yeah.
Yeah, it is a external control plane which is connected to the edge core.
And how is this? How is this name added or mapped to that specific
Okay.
cluster? Do
Okay,
you use some
so
kind of label?
yes, we have
No.
a deployment. Go ahead.
Yeah. So in the code, basically we are using the kubeconfig files of those clusters, Kubernetes clusters, and according to even our document, we have to place those particular kubeconfig files of those particular Kubernetes clusters under edge core. And edge cores etc/4next configs with the name according to a
Here
particular
I
format. Yeah.
Okay, got
cluster name dot kubeconfig.
Okay, I see.
According to that one, we have to save those kubeconfig files.
Cool, thanks.
So now I'm going to deploy into all the clusters that are available with my edge core. So since it is a mission related to deployments, you can even check deploys. Same here too. I would like to request my colleague Ashwin to show the further demos.
Thank you.
Further environments. Yeah.
Let me share. Yeah. So we have I will showcase the demo on these cases. So Click to Cloud was tasked to provide support for multiple clusters on the same edge core level. So we have resolved this. We have raised this PR and resolved this issue, and also tested in 3 different environments. As first case was shown by Nakraju, I will showcase these 2 cases, like one cloud core configured with the multiple edge cores, and that edge core configured with the multiple KTS control planes, and also a hierarchical setup of one cloud core with a edge core, where each edge core is configured with multiple control planes. So let's skip into live demo. So let me up my cloud core 1. This is my cloud core 1. I mentioned it by CC1.
Hmm.
And here I can up my H core 1. So it is get successfully connected with the cloud core 1. I will setting this up for a hierarchical. Let me up with the cloud core 2. So this cloud core 2 is running on the same machine with the H core 1. And we will configure this cloud core 2 with the H core 2. So here we can see our H core 2 is connected with the cloud core 2 and H core 1 is connected with the cloud core 1. So if we want to perform mission deployment, so here we have a YAML. So here we have a YAML of given cluster, and now this H core 1 has connected with the two control planes. Like I have put that config files of these two control planes, like control plane 1 and control plane 2, which is connected with the H core 1. And same like this, cloud core 2 is also H core 2 is also configured with the two control planes, external control planes, control plane 3 and control plane 4. So if you go to deployment, if I provide a name here, if I wish to want deployment in a cloud core external control plane 2, and also in a H core. H core 1. So I will put here name EC1.
So you can put multiple clusters names here.
Yeah, we can put
that's
a single one and a multiple one also here. We have the that fragile mode. We have that functionality also.
Okay.
So if I apply this, so here we can see logs of H core 1. Uh, the deployment is created inside a H core 1 and a control plane 1. So we can cross check that here. If I check here missions, so here we can see deployment here is also we have put it the deployment and also check in a H core 1, sorry, control plane 1. Okay, sorry, I have mentioned here control plane 2, so I will check in control plane 2. So here we can see the deployment is to a given cluster is working fine in hierarchical, and we can also perform same like this uh, deployment to all, like every cluster which is connected with any H4 or in any cloud core, all the deployment will goes to that cluster. So I will go for deployment to all. Okay, so we have got created these missions deployment wall. It will actually the deployment wall will take all a bit much time, more than a bit more than the event cluster.
That's because it's propagating through the cluster, right?
Yeah, it's also in a hierarchical way, so it takes time to find the config files of the that control planes. So if you want to check the missions here, let me check the missions. Now I want to showcase the second case, one cloud core configured with a multiple H4, where H4 configured with a multiple KTS control plane. The second one. So
The difference between the case 3 and case 2 is cloud cores on each edge core configured with.
hello.
Can you repeat the difference between case 2 and the case 3? Case 3 is
Yeah.
the one you're trying to demo here.
Yeah, I have showcased the case 3.
Oh, I see. Okay.
Actually, the one cloud core is connected with a multiple edge core with the at the same edge core level. And here it is in the hierarchical manner.
I see.
Like I have control cloud core 1 configured with the edge core 1, and on the same cloud core edge core 1 we have a cloud core 2, and that cloud core 2 is connected with another child edge core 2.
I see.
So let me set up the second case. So if I want to connect with the edge cloud core 1, so I have to connect this second edge core with the same cloud core 1. So I will provide the config file of that cloud core 1. So we are setting the cloud core 1, and with that we are setting the edge core 1. So here we can see it is connected EC node EC1, that is edge core 1, and we can verify the kubectl command also. So we have a edge core 1 connected, it is in healthy state. And now let me connect with the second edge core. So it is also successfully connected with the same cloud core, like one cloud core with a multiple edge core. So here also we can perform the mission deployments and other in two cases, like to a given cluster or to a multiple all clusters. So if I wish to get deployment in CP2 and CP3, which are this is in a CP2 is in a H core 1, and CP3 is external cloud control plane in a EC2, that is H core 2. So so we can see here we in the logs that is a deployment is created in it is the log of H41, and here is the log of H42. It will take a bit of time. It will get successfully deployed here. We can verify this one like CP2. Yeah, it is in a ready it is in ready state. So I have to verify now. It is taking a bit of time here in H42. So if it will create a successful create AI mission deployment, we can verify in the control plane 3. So likewise this we can also perform the deployment to all clusters. And we are thankful that you have merged our PR in the Fornex.
Yeah, this looks good. Thank you.
Yeah, that's it from our side.
Okay. That's all the demo we have today, right?
Yes.
Yes, Ping.
That's it. Yeah, good work. Thanks, guys. Yeah.
Yeah, this is, I want to say a few words. This is very good addition to the features for Fornex. We have, in the meantime, we have already developed some networking features so that with this, it doesn't really matter how the clusters are connected. With this PR, we can connect them in a hierarchical way, or we can connect multiple clusters to the same edge core at different levels. With that, and with the network feature, we have very strong flexibility for the edge. Just imagine if you deploy your cluster in different hierarchies, and all the application running in those clusters can talk to each other, whether that's for storage, whether that's for MEC kind of scenario, that gave a lot of promising features for the future. So thank you guys for the work.
Right. So that's pretty much it. Anybody else? I know the couple of things I wanted to bring up. Rupal and Mangani, you were there in the Austin conference. How did it go? The Centaurus booth and all that. How was that? The community was interested in finding out more about the project. Can you just briefly? Yeah.
Actually, it was really good. I mean, we got a great traction on booth and session as well, especially on Dr. Song's session. We got a couple of queries around the contribution that we have put for multiple scaling up the clusters, like about 15,000, 20,000 and 100K that we are expecting. So some of the contributors wants to get that published in Kubernetes as well.
So actually, it's 50,000.
Yeah, 50,000, like 2x2, 3x3, and then the future 5x5 as well. So like people are expecting to get that contribution up to Kubernetes community.
Okay.
That's one area. Probably we need to check that how we can get it. We know that process is a bit difficult.
Also, they want to upstream that functionality to
Kubernetes. Yeah. So that's one area. Second, internally we discuss about Magni can bring the other feedback, but there were a couple of people who were interested, came to booth asking about the different scenarios. So I think that's something Magni can give the overall understanding. Just one quick question on this specific area which a team have contributed. I want to understand, are we planning to integrate it to dashboard? Because I don't think that Edge is yet integrated with the Centaurus dashboard. So
I don't think we are there yet. We need to have this discussion somewhere, but that this has not been discussed. The reason is just because the focus of the focuses of several teams have moved on to some new area. But I can bring this up for some conversation. It would be nice to have these features on the dashboard.
Yeah, definitely. As you folks know, I think we talked about that as well. There's been a lot of focus on the regionless, the cloud project. So for the time being, this is kind of not on the back burner, but it's kind of a lower priority. But this is the work which you guys have done is very important, actually. So obviously this is going to come back. And by having this hierarchical support for hierarchical topology, all those things are very useful, obviously. So this is good work. And other things, Mangri, you want to add something based on what you noticed in the conference?
We had 4 talks, so actually saw people joining, like the same people joining each of the talk because they're interested in the topic.
Yeah.
That's very good validation for our work. And then I think I talked to one person. He also mentioned that it will be good to see where Octos is being used. So actual use case would be nice. Yeah.
Okay.
Yeah, a lot of people join the talk and then they stop by the booth and ask more about the project. So I think.
So I'm pretty sure there was a lot of interest in the scalability aspect. The 50,000 nodes and all that. I bet you a lot of people must have asked about that.
And then there was also people asking about Mizar as well, the network.
Mizar as well. Okay, good. Good.
And then the Quark container, and then also the network policy. I think they were all pretty good. Mm-hmm.
Yeah, I think so. That's another thing I wanted to mention. I know most of you guys, folks, were there in the previous month meeting as well, where Yulin presented Quark container. So that's another good project going on. So if you folks were interested in it, start going. There's a lot of documentation in there. And then I mentioned a few things. So just to kind of give you a background, I think we mentioned that as well. So the Quark container was forked from gvisor, the Google gvisor, the hypervisor, the lightweight hypervisor code base. So one other thing is we've done a lot of optimization. Obviously, it's rewritten in Rust, and there's been a lot of optimizations done. But those optimizations, for example, they use the queue mechanism to kind of do the syscalls outside the queuevisor. So all of these things, there are a lot of. So if you're interested in it, start going through the documentation, and then you can maybe work with our team to kind of enhance the documentation. So that's one of the things I asked for, that this optimization using queues for doing syscalls outside the queuevisor is a very important feature, actually. So, but it's not documented well. So it'll be good for community to understand how those queues are built out. So if this is, these are the kind of things you can start getting involved in that. Try to understand if you're interested in it. This is a new next generation containerization beyond Docker. So if you're interested in that, start going through that, and then maybe document it. As you document, you will understand more, and then work with our team. So that's, I just wanted to throw it out there. That's one of the opportunity as well, because there's a lot of effort, there's a lot of emphasis on the Quark container project. So. Anything? Hi, Prashant. I see you there too. Hi, Prashant. How are you?
Hi, Deepak. All good. Hope everything is going well.
Yeah, everything is going
well. All the information I saw the demo. It looks very exciting and.
Yeah. Good work. Good work.
Yeah. And I think the most important aspect of this overall thing was the performance ability on the scaling cluster, what we saw in the conference. Of course, end-to-end scenario and use cases were something that people were looking for, that if we can implement in the real-time scenario.
Yeah. I think that's where I wanted to kind of bring it up. A good thing that you came to this meeting. So as you know, that we got the approval for non-TSC members to participate. So I think it'll be good for everybody to kind of go out and reach out to folks who may be interested. So, for example, somebody wants to implement a use case, using Centaurus. So if they can come to this meeting, propose something, that would be a good thing.
Yep. We are also planning CodeFest 3.0, like every year we do. This year we have been sort of like going to put Centaurus in the front, side and left, like in the middle. So make sure that people get good visibility on the Centaurus community. So we continue to increase the participation from the community further. So that's the goal, to increase our presence. More to build ecosystem support.
I know by your community, you work with a lot of telecom customers. So this time around, if we do that, that meetup, we can talk about Fornex project. Last time we just covered Meetsar and Octos. But this time around, we can, talk more about Fornex project, the edge computing.
Correct. And I was planning to come to Bay Area to meet Arpit, Tajpuria. So if you are around, then we can have a group discussion with him. We can showcase whatever we have done and how the even Linux Foundation and his ecosystem can leverage some of this.
Sure. Arpit, LFH guy. Yeah. Good. Yeah. So I think so. Let's keep it going. I think this is good. Very good. I think the work which you folks have done. So the only thing is, because at this time, the emphasis is not on Fornex, at least from our side. So if you see any opportunity, keep working, keep enhancing Fornex. Eventually, obviously, edge computing is very important. Everybody, all cloud providers are moving in that direction. In fact, more processing is going to happen on the edge. Everybody's saying that. So
that's right.
Yeah. As opposed to the central cloud level. All of these things are going to come back. So other than that, anybody wants to chime in, anything, suggestions or proposals, feel free. And other than that, I don't have any. We don't have any other agenda item. We pretty much covered the housekeeping and we covered the demo. And
is there any new projects other than the one that we just got in integrated that we are planning?
No, so there are a lot of projects actually. So so as I said, the whole Centaurus is kind of transitioning more towards Centaurus 2.0. So one of the key goals, actually, I don't know if you were there. I think Dr. Shaw, you met him at that in the conference, isn't it?
That is right. Yeah.
So he might have talked about this regionless cloud.
Regional clouds. We spoke about that.
Yeah, so which is very important. None of the cloud providers do that, actually. If you go to any cloud, any Amazon, Google, or Ali, or whatever, you have to pretty much say which region you want to deploy your application, or create a VM or whatever. But that model doesn't work. So you don't really utilize all your regions efficiently. So what we are working on is, which nobody else does, is regionless cloud, basically. So the developer doesn't care what region, depending on the requirement and the resource availability and the SLA, will deploy to whatever region. Behind the scene, you may have 28 regions and 100 data centers. It shouldn't really matter to the developer. There's a lot of effort, because it's not that easy. It's not just because the problem is all of these key value stores, XCDs, and all of these are very tied to region level, basically. Once you start, and Pang actually is the one. He's spending a lot of time and effort to kind of solve all those hard problems. So what happens to some kind of a key value store that stores the cluster information and that goes across regions? How do you do that? So these are the hard challenges Pang has been, his team has been working on, actually.
Yeah.
Any work on the replication between the regional data?
Exactly. That goes along with that. Exactly. Yes. Yes. Yes.
Got it.
So it's not just a key value. When you build a across region key value store, you have to worry about replication. Exactly. Yes.
Yeah, that's good. I would be very interested in seeing how this shapes up in the near term and longer term. And Pang is like really a smart person, so I know that he can drive those things in the right direction. So
Yeah, maybe if that's something we can see if we guys are interested. Maybe he can some kind of a demo. I know you have some demos actually, so maybe we can in the next meeting or so. Maybe we can give them a high level flavor of what we are
Oh
doing.
yeah, absolutely.
Yeah,
I want to add a few things. One is the current, as Deepak said, the storage we're working on is trying to offer storage at the global level, or the quote unquote the regionless level. Is not tied to a region. And we have, we could prepare something for demo next time. Also, actually, in my mind, what's in my mind is the solution we are developing. That's based on the fact that between regions, the network is all connected, right? We assume we have a bunch of storage instances. We provide a layer on top of it, so that for the user, they don't have to care where the data is stored, but the assumption of this whole thing working is all the storage instances in different regions, they can talk to each other. And if you put that picture into the Fornix picture, eventually there's a very good opportunity for them to work together. So what I'm saying is the regionless storage that has also potential for the edge. So the top layer can be deployed on some clusters on the in the cloud or somewhere on the edge, and the storage instance can be managed throughout different edge clusters. And we already have the networking side. We have the work from you guys to set up different ways to have this cluster hierarchy. And once we have, since we already have that, and once the storage side is ready, then we can also try deploying the storage clusters on the edge. And that would be another possible usage for this storage project.
is it possible to create like an agri kind of a use case scenario on the edge site? You collect like IoT data, and then that gets back to the Centaurus, or like some way to connecting to the regional cloud, and then you keep collecting the edge site data on the regional cloud itself and do a BI on that on top of it.
Yes. Actually, it goes beyond that. The potential is that for the edge user, you can deploy your application here and there in different clusters, and then you can use this storage as a way to share data. So one application on one edge from IoT device, it can collect some data, and then store in this the storage. The application does not have to think, okay, I need to send this to other application on some other edge. The application does not have to do that. It just put that in the storage, and because the storage is shared across different clusters, some other, for example, the same instance of this application on a different edge cluster can pull that data from the storage. That application also does not have to know where the data come from. It just see that, okay, we have this key, we have this value, it's in the storage, it showed up, and then they can start to use that.
Can you help us create one architectural diagram, Pang, on either taking care of like medical or healthcare related scenario or agriculture scenario? I'll draw it on pen and paper and send it to you, and you can help us like complete that scenario. I was thinking like maybe like ICU control units or some radiology unit talking directly through TL7 or something with the edge site, and then edge site transferring data to the central location. Very unique example for healthcare, like maintaining the critical units through portal.
Even the mobility aspect as well, though. For example,
Yeah.
if you're playing a game, cloud game, okay, and you're playing that game on the edge, okay?
Yep.
So because you're moving, you're playing that game, and you know, in a car or whatever, you're walking. So as you move from one edge to another, it should be seamless experience. So the state which the game state which you built in edge one, it should be automatically available in edge two because you moved near to edge two now. You see, so it should be all seamless. So all of these storage problems which we are trying to solve are going to address all those mobility. So IoT doesn't have the mobility aspect, but there are so many use cases for mobility when it comes to edge. You see.
Agreed. Maybe we can start on one use case, Deepak, and we can continue to contribute on that use case in partnership with Pang and you guys to build at least some scenario for upcoming sessions on the Code Fest or upcoming time.
Yeah, definitely. Oh, that sounds very good. Yeah, that sounds a good idea. Yeah, definitely.
Yeah, absolutely.
Yeah, this storage, the way storage is shaping up, the whole edge thing is gonna be very different. So it's the way storage is currently, designed on the cloud, center cloud level is gonna have a very different experience, and the way to design it is gonna be very different.
In fact, one of my friend, like who's building some hardware for the public announcement system, especially for the railways. So for the trains, right? That the tram system in Nagpur city, he designs that, and he was asking like, can he have a PA system on the edge site because all these trams are running parallelly.
Yeah.
And then they can collect a lot of data on where the train is and what announcement needs to be made and who needs to be communicated about those things.
Yep.
Yeah, like an emergency system and all. Those are like really great example. But let's start with one simple one. Maybe I can ask team to put a basic diagram and then they can work with Pang to solidify it, and then we can present.
So I think this would be good. So essentially what you're proposing is, so the work which you just showed, the demo, this was more kind of a, work. Now, more like a technical enhancement to be able to support hierarchical topology. Now, correct. I think the good thing would be to build a use case, actually.
Yep.
Mobility use case or IoT use case or whatever, the tram use case.
Yep.
And then leverage Fornex and the storage, thing which we
and
are
AI
building.
basically, yeah, like
and
the
AI,
whole Alnair,
yes,
whole Alnair part of it. Then the whole story of Centaurus comes together.
Because like that's what the end people community is interested, because for them 50,000 nodes in a cluster, or it doesn't unless you kind of weave a story around this whole thing, people don't understand that.
Absolutely, that's what I'm talking about.
Yeah. Oh, that would be good. That would be really good, actually. If we can build a use case, have a story, mobility story or IoT story to go along with the Fornex and the storage, how the storage is going to work out on the edge.
Yeah.
That would be a good thing to do. Definitely.
Yeah, we'll draw something and we'll send it to Pang and the team, and then we will take their directions from there, like how, and in fact, some pieces, how do we in fact integrate the Alnair pieces too, like the whole AI.
Why don't you, Prashant, why don't you do that? Why don't you in the next meeting, why don't you guys just do brainstorm, just do some quick and dirty kind of thing, and we can brainstorm next meeting. How about that?
Absolutely.
Let's do that. Yeah. Let's do that together.
Yep. Cool.
Yeah. So why don't you put that in agenda and then have some very rough sketch, and then we can brainstorm that. See, and then carve out a use case that leverages the current Fornex, because I think we have enough meat in current Fornex project, and plus the future storage work, and then kind of carve out a good use case out of it.
Absolutely.
Yeah, let's do that.
Once you have that before the next meeting, can you send that to me so I can prepare something based on what you have? And also I'll incorporate the storage, some thinking from the storage. Some demo from the storage side. So we have a consistent story working towards one single goal.
That will be good. That will be very good. Yeah.
In fact, we'll do it under your lead only, Peng. I want you to basically drive and guide us to the technical guidance. I mean, we all know that you are a very smart guy, so you can help us with the right direction.
So why don't you? Okay, so yeah, that's a good. So basically, we'll have a joint kind of a brainstorming session next month. But in the meanwhile, Prashant, feel free to reach out, send out all the information to everybody in TSC.
Yep, absolutely.
Send it to everybody. The folks, actually, the TUVN guys, they have done a lot of work on this edge. The Stefan and and then Professor Dustra. So there, so just send it out to everybody.
Yeah, absolutely, absolutely.
Okay.
Great.
Good.
Wonderful.
Thank you very much. Thanks everybody for joining in, and then we'll see you guys. So hopefully, why don't you guys put that in an agenda item, and then in the meanwhile, we'll solidify what we want to discuss, and then we can discuss that next one.
Yep, absolutely. Thanks, guys.
Perfect.
Okay.
Thank you. Bye-bye, everybody.
Right.